Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Aaron is off in Southeast Asia, I believe, in Bangkok this week. So there's potential he's never coming back, depending on how his nightlife goes. But hopefully we'll see him back next week for the next show. Nevertheless, we're always excited when we get a chance to talk to a new company. And today we have a company, a brand new company who's out in the public, but just a little bit before going to be shipping some products. So we're excited to have Sumeet Singh, who's the founder and CEO of Appformix. So Sumeet, welcome to the show, and give us a little bit of background in yourself and Appformix.
Hi, Brian. Happy to be here. So we are Appformix. We're just emerging from stealth. And at Appformix, what we are focused on is enabling enterprise IT to run their infrastructure in a more streamlined fashion, to be able to essentially truly get all the benefits of the cloud within their enterprise environments, and as they expand, into the public cloud in some kind of hybrid cloud model.
Okay, your background is pretty extensive from an engineering perspective, pretty diverse. Give folks a sense. We always like to find companies who the founders, not only have sort of lived in the trenches for this problem space, but have developed things that were the foundation for where the next thing goes. So give folks a sense of not only your background, the companies you've started and sold, but also the types of things you built at some of the larger companies like Cisco and Microsoft and others.
So I started my career several years ago, actually 20 years ago, at this company called AirTouch, where I was designing a performance and network management system for cellular operations. AirTouch is long gone, merged into bigger things. But from there, I went on to do my PhD at UCSD. Unfortunately, I never finished because I took my thesis at that time and spun it into a startup coming out of UCSD, which was eventually acquired by Cisco. But what that startup was about streaming algorithms, about taking data at very high speeds and processing it and converting all of that noise into signals that were easy to consume, right? And in that case, we took all of that research, all of that work, and used those techniques to build better security products. And took that company into Cisco, took the technology, deployed it into various Cisco platforms, and spent several years at Cisco just building big networking gear, looking at how to, let's say, make networking gear more programmable. And that's where I got introduced to OpenStack very early on, very, very, very early on. In fact, even before the first few OpenStack companies were funded is when actually Cisco started looking at it, and I was looking at that, and I got interested in the cloud. Cisco had several projects spun up to look at the cloud, and it was a very interesting space. And a lot of the work that I had done previously, in distributed systems, in data analysis, in analytics was very applicable. And, just kept going deeper into it, kept going deeper into how networks would be more programmable, and SDN kind of came about. Lots of interesting times. But then from Cisco, I went on to Azure, which was at that time growing at this insane rate. It probably still is growing at an insane rate. And it was a very good environment, like lots of smart people working on challenging problems, all the time. And it's working with large scale infrastructure. And, when you do that, it's an eye-opener. Sometimes even the products you've designed previously, when you kind of are in this new environment and you think about, hey, this is how I designed the product, And this is how it's actually used in this live environment, and this is the scale of this live environment. And you really realize that you got things so wrong.
Right.
And
Yeah.
it's a complete eye opener just being in that kind of environment.
Right. And you were designing a lot of the sort of early SDN networks for Azure, correct?
Yeah. So the early SDN network was already being developed when I joined Azure. They were just in the process of putting it out. What I came in and worked on really was extending it to the hybrid cloud, so making it easier for enterprises to connect with Azure, and that's the service me and my team built, and then released it, and then just that process of building a service, releasing it, seeing the uptake on it is at that large scale is just such an awesome experience.
You took some learnings from there. One of the biggest things that I always find in talking to different people is, it's one thing you talked about. It's one thing to build at certain scale, and another thing to build at a bigger scale. But the other thing I hear from a lot of people is, a lot of people don't understand the nuances or the complexity of building in sort of truly shared infrastructure where you have multi-tenants, maybe not always, complete isolation between the tenants. You've got, shared network infrastructure. Like, talk about some of the things that you guys learned, not only from doing it at Azure, because again, it was at scale, but what you took from that and sort of what you're looking to turn that into from an Appformix perspective.
What it really comes down to is there's a right way of doing things and there's a wrong way of doing things. And the right way is right regardless of the scale. And let's just say what Azure was for me an eye-opener on what's the right way to do things. So simple things like, to design for infinite scale, or you have to have systems that are autonomous. You have to account for things that that service has to continue no matter what kind of failure there is in the path. And that's really, I think that would be like the key learning there, that failures always happen.
Yep.
You have to have the tools in place. You have to have the instrumentation in place to be to realize what the failures are, potentially even before they happen. And then, of course, you have to build software in a way where you can kind of even in the face of failure, continue to operate and ensure that your customers don't see any disruption.
Right.
In that same spirit, it's a large multi-tenant environment. Cloud infrastructure is generally, it is fundamentally shared infrastructure. So it's critical. Security is critical. Ensuring that that no one tenant can disrupt the service of any other tenant. And so just building for scale, building for security, building to work around failures, putting the tooling in place, putting the operational practices in place. Things like, when failures happen, the extent to which you go to analyze why the failure happened. Just having that cadence, it's you just got to have it. You got to, follow everything through, not leave anything unfinished.
You talked about you helped sort of extend some technology. You built it out to a new place. You got it launched. What talk about what drove you to sort of want to get back to your entrepreneurial roots, your startup roots, and get the company started, and sort of what was the core problem you felt like was going to be solved with your technology?
So the core problem, or at least what I saw as an opportunity, at heart, I've always wanted to work on my own thing. So you work in large environments. You work with great people. You learn a lot. You're getting to work on large infrastructure. But really, in my heart, I wanted to go back to my roots and start another company and really truly put myself in a position where I could apply the last 10 years of learning and not just the last few years of learning, let's say. And that's really what Appformix was about. So if you look at the cloud landscape, and if you look at what Azure does and Amazon does and Google does, I mean, these companies are innovating so fast at such a rapid pace that it's practically impossible for enterprises to keep up with them on their own. It's impossible for smaller service providers to keep up with them on their own. And increasingly, more and more and more services are being delivered in software. So if you need to compete with these guys, or even if you not need to compete, but if you want to play with these guys in the future, because if you look at the template for the hybrid cloud, then what you need is that in the stack that you have running in the enterprise and the stack that you have running in the public cloud, they need to be very aligned, right? You need to have the same kind of tools that you use in-house. You want to use those same kind of tools in the cloud. You want to have the same software run in both places. You want to have seamless infrastructure in both places. And Appformix then in that context was about ensuring that, that innovation engine kind of continues, that, hey, we can deliver to enterprises and we can deliver to smaller service providers capabilities that you would need to interoperate with these larger clouds like Google and Amazon and Azure.
Whenever, I'm talking to providers, a lot of them are, that's what they're trying to figure out. And the nice thing is, in a lot of cases, they have a very strong relationship with their customer base or a growing customer base, but they just can't keep up with, bringing the same types of technology, and then they get themselves stuck into a, sort of race to the bottom, or just competing on price. So it's powerful that you're trying to take some of that knowledge that you have from live expertise at an Azure and one of the large public clouds, and then trying to bring that from a software perspective to help them out. Now let's talk a little bit about the technology itself. Obviously we're talking live. This would probably work better if it was on the whiteboard, but give me the core kind of sense of, how the technology is looking at the infrastructure, the breadth that it's looking at. Is it looking at compute, storage, and networking, or, give folks a sense as best you can in terms of what exactly it's doing.
Yeah, so what really we're hearing from customers is essentially this new message, which says the new stack for new applications, right? I mean, so we've all been virtualizing for several years now, and VMware was kind of like the flag bearer there.
Right.
But really, what it's about now is that next generation of services, and building those next generation of services, you kind of looking at the template from the cloud, like how you would build the service on like a cloud infrastructure like Amazon, perhaps, right? So even within the enterprise, you want to have that new kind of stack now that enables you to deliver services or applications internally in that kind of a model. And in that model, if you look at what's really going on in there, you see cloud teams popping up in these enterprises. And these cloud teams then look across the silos. They don't work in like network or storage or compute. They are the cloud team. They look across all three of them. And if you look at each one of these three segments independently, like storage, compute, network, all of them are even more and more software defined now. And what's happening is that all infrastructure is getting converged. Right. You're getting some management stack like OpenStack or Kubernetes or Mesos that essentially takes these individual servers, these individual cores, and makes your entire cluster or data center appear as essentially one big server. It gives you that abstraction. You get your storage, you get your network, and it's all seamless. It's all managed like in using this common abstraction. And that's roughly where we are kind of inserting ourselves as well. So in this new world where you have new this new stack for the new applications, where it's more converged, where the teams are more converged. What Appformix provides to these enterprise IT is this new way to analyze how your infrastructure is being consumed by all of the workload that's running on top of the infrastructure. You can think of us as sitting at the intersection of the applications and the infrastructure. As any of the orchestration engines deploy more and more workloads onto the infrastructure, we are then in real time able to analyze how each of those workloads is performing. Are workloads contending with each other for resources? Is there anything in your infrastructure that's being a bottleneck to the efficiency of your workload and things like that?
Gotcha. Now, digging in just a little bit, I know you guys are still sort of in stealth and in beta, but just at a basic level, how do you go about capturing the information? Is it agents within containers or virtual machines, or how are you collecting information not only about kind of a specific customer's set of resources, but maybe at a cloud or provider level, what else is going on those resources to make intelligent decisions?
Yeah, that's a great question. So our initial market is the enterprise cloud. So what we are looking at is cloud clusters that you spin up in your enterprise cloud, let's say either using OpenStack or using some kind of management framework to manage those clouds. In terms of deployment, our solution has several different parts. The first component is, of course, we have an agent that sits on the host. And what's unique about us is that what we have is an agent that's deployed on each one of the hosts. And what each agent is doing is not only collecting the resource usage metrics on the host, but is also analyzing all of these metrics in real time. So we use a class of streaming algorithms to do all of the analysis in real time. And again, taking that a step further, we are able then in real time to correlate these cross-domain metrics. So as in what's the relation between the CPU and the network, or the memory and the storage and things like that. All the analysis happens in real time. So what leaves your server is consumable signals that are already giving you good pieces of information as to how your infrastructure is performing. Right? So that's the first order thing. Built on top of that is we have an analytics engine that consumes all of these signals and then can help you better plan your infrastructure. It can tell you where you're being wasteful in your use of infrastructure. It can tell you where you need to deploy more infrastructure, or when you're going to run out of infrastructure even. And in that same spirit, it can also influence your application schedulers. It can arm them with the information so that they can better place the workloads on the infrastructure to extract the maximum ROI from your infrastructure to essentially get the best performance possible from your infrastructure.
Okay. Yeah, that was, and that sort of touches on what was going to kind of be my next question. So it seems like you're going to have a mechanism. Obviously, you're collecting information in real time. You can generate information that's useful from a monitoring perspective, but you're also going to be able to feed information back into an OpenStack, a Kubernetes, a Mesos, one of the other scheduling things to give it some intelligence that it can use to make better placement decisions.
Absolutely, that's really what's key, and that's how we fit into the ecosystem. Like, as part of the technology that we built into the agents, you can start off with a simple agent that kind of looks at the usage metrics on the host, but We also have a more sophisticated and advanced version of the agent that can actually introspect all of the I/O transactions that are happening on the server. And that information is currently not available. So essentially, if you look at any scheduling algorithms today, they mostly account for CPU and memory availability. They do not really account for, hey, these are the number of transactions, I/O transactions that the application is doing. This is the capacity of the server and things like that. So we then, in that context, enable a more informed decision-making process for the workload placement that is inclusive of the I/O in addition to the CPU and the memory. So
okay. Yeah, that makes sense. I know that you're still in early days and haven't, you're, like I said, you're still in beta. Beyond, say, some of the scheduling things, that you're collecting a lot of information about monitoring and, kind of status of what's going on. Do you have intentions, or have you identified partners that you expect to work with that, do some higher level things, maybe at an application level, a Datadog or a New Relic, or any of the logging companies? Have you started to look at, what you think are the other places where your information becomes additive or complementary to services that you hear from your early customers?
Yes, we do. So so it's great that you bring up these examples, because they come up often. And so if we think about the ecosystem as it exists today, over the last 5 or 6 years, this whole application performance management space, it's just been going phenomenal, right? I mean, it's been growing like insane. You have New Relic, you have App Dynamics, you even have Splunk,
right?
But fundamentally, what each of these products is doing, right? I mean, especially if you think about New Relic or App Dynamics, what each of these products is doing is it's trying to optimize the performance of a single application. So, for example, you have application A, you use App Dynamics to optimize, let's say, or find, troubleshoot, ensure that application A functions correctly, right? Then you use App Dynamics to ensure that application B functions correctly. But really what's happening is that it's trying to ensure, performance for A and performance for B in isolation of each other. Same for New Relic. What we are trying to do is essentially be the counterpart, let's say, at the infrastructure layer, right? I mean, we would potentially bucket ourselves as the counterpart for infrastructure performance management, where we want to be able to deliver the right infrastructure so that, even though that each one of those applications was being optimized independently, when they're deployed on that same shared infrastructure, you collectively get the best performance out of all of those applications.
Gotcha.
Right.
No, and that makes a ton of sense, especially, if we sort of circle it back to what you talked about, which is things are becoming more and more software based, and people want to leverage. In some cases, they want to leverage in-house resources, and in other cases, it's going to make more sense to put things out on the public cloud, and you want to be able to say, either one of those could be unknown to you in terms of what the resources look like and what's really under the covers. And you want to be able to give that level of control to people that, may postpone that decision if they think, well, if I don't know what's out there, I'm going to be hesitant to do it. And it's powerful that what you're trying to do is give them visibility so they can see what they're getting themselves into, and sort of proactively keep up with what's going on with it.
Absolutely, yeah, and as I was saying, beyond the visibility part, it's the control capability is very core to our technology as well. You have this shared infrastructure, and then the question then always is that how are you sharing the infrastructure, right? And just as I was saying, existing schedulers, they take CPU and memory into account. They kind of try and place virtual machines or containers to optimize use of CPU and memory, but when it comes to I/O, it's a shared resource still. And there's really no partitioning. There's nothing. Everything that's running on that server it's almost using the I/O as a free-for-all resource. So as part of our agent that we installed, the advanced agent that can do the advanced I/O analytics, it can also consume policies that are kind of provided by these orchestration engines to partition how the I/O is consumed amongst the different workloads that are sharing the resources.
Gotcha. So, makes sense. How, as you move from sort of stealth and beta into closer to GA, how can people expect your technology to be packaged? What would you expect the go-to-market to be like? How do you expect customers will engage with you to get the software, whether it's for demos and POCs or for further into dev, test, and production?
So we are looking at a couple of different models. First of all, let me tell you what our full stack looks like.
Okay.
So we talked about the agent, but let me tell you what our full stack looks like. So there's several different components. The first component is, of course, the agent that's installed on the host that that can both learn the metrics, analyze the metrics, and generate consumable signals for you.
Mm-hmm.
And again, in this context of shared environments where you have your host, you virtualize them, or you've containerized them, and you're spinning up VMs, you're spinning up containers. What's unique about our technology is that it's this single agent that installs on the host, and then no matter whether you're spinning up VMs, how many VMs, containers, how many containers, we do not touch any of that layer. So just that single agent, it can give you all of the metrics for the host, or give you all of the metrics for the VM as well, and what the footprint for the VM looks, the resource usage footprint for the VM looks like on the host, right? The next layer up is our analytics engine that can consume all of these signals and create for you KPIs that you need to watch for in your infrastructure. So, for example, very quickly we can tell you if your infrastructure is healthy or not, what's at risk in your infrastructure, if you're running out of resources, if something is wasting resources. All of those key metrics we can inform you about. The next layer up is this central, what I would call is a central manager. And the reason I call it a manager is because it's purely built for the purpose of consuming your policy and distributing it to all of the hosts.
Okay.
Each host works autonomously. The central controller, central manager is purely for the purpose of you make the API calls to it. We are an API first system. Each layer of our system exposes a well-crafted, well-defined API, and you make your API calls, and this controller piece automatically ensures that the policy is implemented in all of the hosts where it needs to be implemented. On the side of that is this interesting thing, this question about how will people consume us. So we are targeting our solution to clusters. We are targeting our solutions to clouds. And what that means is that you're running several servers put together as like one single environment, as a one single server. So what we have built are plugins that can learn from your management/orchestration system. So for example, we have a plugin for OpenStack, which can automatically learn from OpenStack what your infrastructure looks like. What's the host, what are the projects, the tenants, the aggregates, the VMs, whatever it may be, we can automatically learn everything. And even the installation process is fully automated. You say go ahead, and we can install the agent everywhere automatically.
Oh, okay.
Similarly, we have a plugin for Docker where we can auto discover everything, your Docker environment, your containers, and again make them all visible to you. So in our world, we kind of assume that there will be a management orchestration engine that the customers use, and we work on the side of that engine and we learn everything from that management system and make everything available to the customer on our system as well. And then as and when changes are happening in that management system, we are hooked onto it, and we are always in sync with that the change in state in that management system.
Okay, good. Yeah, no, and that's obviously very smart. A lot of people sort of always build their system in a vacuum and then, assume that people just want to use their system. So the fact that you can just kind of auto inventory, auto discover what's going on and get into that workflow is very powerful. So, yeah. Well, listen, I think we've dove into this a little bit. Obviously, anytime people can play with the technology, that's better. Give us a sense of when you'd like people to start reaching out to you, whether it's wanting to be part of betas or getting early access to things, and then where can we expect to see the company out and about, or what's the best way for people to engage with you?
So we are actually already out and about. We have several installs already, which are in production environments. We're learning a lot, and we are improving rapidly. We currently are on a 2 weeks release cycle. And of course, as we get closer to GA, in the next few months, our initial go-to-market is going to be through our partners. We have a close partnership with Mirantis. Mirantis is the leading OpenStack distribution.
Yep.
So our software will be available as a Mirantis Fuel plugin, and if you're running a Mirantis cluster, it's going to be very easy for you to just download, install, and get it running in the cluster. Yep. And following from that, we will announce more partnerships and the goal really is to make the software very easy to consume. Initial deployments are entirely on-prem, where you install our software, you install all of the components on-prem. Our software itself ships as Docker containers.
Okay.
It's very easy to spin up, very easy to scale. And eventually, in the future, we are looking at having a SaaS version of our software as well for the smaller deployments. But at present, all of our customers are large enterprises who want that everything in-house. They want control over their data. And, so initially we are focusing on that on-premise environment.
Okay. No, that makes a lot of sense. And again, it's augmenting those skill sets that a lot of times customers want to have a cloud, but don't always have all those sort of skill sets in-house and are looking to augment it with good technology. So, well, listen, thank you so much for all the insight on this. I think, like I said at the beginning, we love kind of talking and finding out about new companies and companies that are just on the brink of sort of getting out into the public space. We will have links to the Appformix homepage as well as some other things in our show notes for everybody who wants to go follow up. And, Sumeet, excuse me. Any last sort of things you want to touch on before we wrap it up for the day?
Yeah. So, if I could just summarize, just a quick summary about Appformix. So there's three key things that I would like to deliver for my customers. The first one is infrastructure transparency at scale, right? Large infrastructures, I want my customers to know exactly how their infrastructure is being consumed, right? I want them to know how they can get better efficiency out of their infrastructure. The next challenge is, being able to identify and fix bottlenecks as they occur in the infrastructure. And as part of doing that, we want to enable this new policy-based resource utilization, especially when it comes to I/O resources. And then eventually, just as things are in the cloud, right, like where people design their applications, and while they're designing their applications, they have access to all of these APIs that are constantly informing them how the infrastructure is behaving, and that allows the applications to make better decisions on how to scale back, and things like that. We want to enable that set of APIs that users in the enterprise can use to better design their applications. So,
No, it makes a lot of sense. I think the combination of your background in this space in terms of both from a PhD perspective around complicated distributed systems, and then having worked in the space is very powerful. And then thinking about how you're packaging it, how you're going to market seems extremely well thought out. So with that, I'm going to go ahead and wrap up the show. Sumeet, thank you so much for being on today. For Aaron, who will be back next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.